Welcome back, everyone. This is part 2 of the functions test study guide session. I'm dealing with topic 2, where we're talking about parent functions, transformations, and graphing. I asked you to cross off the cube root function because we didn't talk about that, and the greatest integer function, we didn't talk about that. We focused on these 6: the linear, the absolute value, the quadratic, the cubic, the square root, and the reciprocal function. I asked you to give the parent function and sketch a graph. And this is what you should, this is what you should have. Notice that every single one of these functions, well, with the exception of the reciprocal function, goes through the point 0, 0. That's known as the vertex. Right? That's our anchor point for the parent function. And that anchor point comes from this parent function, or it comes from this idea, x minus h plus k, that h, k are the xy coordinates for the vertex. When there's no change to the parent function, h and k are 0, 0. When I start making changes to the parent function, then h and k become the corresponding, the coordinate that corresponds to the movement left or right. So keep that in mind as we move on to these next problems. I know that I asked you to cross off 16 because it deals with a cube root function. 18 would be a challenge level question, maybe an Aspire 2. I had you cross it off, but if you'd like to do it, you certainly can. It was just that we haven't talked about greatest integer function, but all of the same transformations still apply. All right, I think that's it. So let's look at 15. A quadratic parent function. So immediately I'm thinking x squared. If you're visual, you're thinking parabola. It's been reflected in the y-axis. Okay, so the x values have changed their sign and vertically compressed by a factor of 1/2. That means it's gotten shorter. Write an equation to represent this new function. Well, the reflection in the y-axis happens by negating the x values, and the 1/2 is the vertical compression. Okay, in 17, the absolute value parent function, so I'm thinking of absolute value of x. If you need the visual, it looks like this. It has a transformation applied such that it creates an absolute maximum at -2, 7. Okay, so now, if it helps you to think visually, it has an absolute maximum at -2, 7. So how has that function moved? Well, it's moved to the left 2 and up 7. Remember that when we talked about the new vertex, h being how it moves horizontally, k being how it moves up, if it moved horizontally by 2 units, left and up 7, that's where these numbers come from, right? My h would be -2 and my k would be 7. So here, this negative represents my reflection in the x over the x-axis. The positive 2 represents a left 2, and the 7 is up 7. Okay, in 19, all the transformations that happen here, it's cubic. So if I'm visual, it's looking like this as a parent function, right? X cubed would be the parent. And then the transformations that take place, well, I'm going to go in order here. It's going to be a vertical stretch, well, a horizontal stretch by 2 because of this 1/2. So that's the horizontal stretch. Anything that happens to the x, like inside and around the x, happens horizontally. It could be a shift left or right, or it could be a horizontal stretch or shrink. In this case, it's a horizontal stretch by a factor of 2, right? The fraction will always make something fatter. So I always think fraction starts with f. It's going to make the function fatter. The language I'd like you to use is that it's a horizontal stretch by 2. Okay, that 3, because it's happening outside of the parentheses, it affects the y value, so it is going to get taller or be a vertical stretch by 3. The negative has a this function reflected over the x-axis because the y values are going to change their sign, and then this moves up 7. So doesn't move left or right, so the new coordinate for the vertex would still be 0, but because it moves up 7, the y coordinate is positive 7. Right? So it goes from being anchored at 0, 0 to now being anchored at 0, 7. Now a bunch of other changes happen to it, but that anchor point, that vertex point, just moves up 7. And lastly, all the transformations that happen here. We're going to see a vertical compression by 2/3, which means it's going to get shorter by a factor of 2/3. It's going to be reflected in the y-axis because of that negative. It's going to move to the right 5 and up 2. Okay, now, last part of this. I'm going to graph each function and identify all of the key characteristics. Let's make this the next video. I will see you in part 3.